Perfect. There it is. So this is your entry level, which is CCT, and as you can tell, it's basically a starting point. So anyone who would like to start into networking world, um, this is your opportunity to step into Cisco's networking world. Anyone with an IT background, or anyone who's and deciding to get their feet wet into data center and Cisco's world, this will be a great opportunity for you, which is CCT. CCT stands for Cisco Certified Technician. As you can tell, I am a CCT certified. This may look a little different. The reason why is because Cisco changed their certification path in March, and I happened to take it right before they changed the certifications. As you can tell, I took it on March 5th, and I believe they changed the certification path, and going into March 18. Um, but but yes, Cisco certification is going to be a good entry point. Uh, my focus in this channel is to is to gear towards CCNA, and it doesn't matter. Let's say if you're still studying for CCT, those topics will also be covered into CCNA, and there will be a few additional topics once in a while, but this is something that that's going to be on your list going forward. So it's good to take notes, and it's good for your educational background too. So in today's focus, I'll be focusing more on CCNA, and yeah, and let me click on CCNA, and I'm gonna get some exam topics. So those who are familiar with CCNA or CCNA, you may or may not know, but they changed the exam, and this is the newer exam, which is 200-301. Um, and you can tell this is version 1.0, which means they just came out with the exam. Your timing hasn't changed. It's still 120 minutes, so 2 hours. And timing hasn't changed, but your topics has definitely changed because, as we all know, that technology world is constantly changing, right? And new standards and new devices with new protocols are being deployed. Uh, which run more efficient, and they do a lot more than than what they used to years ago. So really quick, I'm gonna go over some topics, some key topics. As you can tell, this is your network fundamentals. So you have your routers, you have your switches, you have your firewalls and IPS access points, Cisco DNA, wireless hello controller, endpoint servers. So nothing big going on, right? Nothing huge, nothing crazy going on in this case. Um, So just your foundations, layer 1, layer 2, layer 3, introduction 101 to what switches do, what routers do, what access points do. Cisco DNA Center, that's something new because, and WLC. Cisco DNA, you'll see that a lot. It's still work in progress, but you'll see it's Cisco DNA, it's Cisco's approach um, or Cisco's approach to create a platform to build automation. Hopefully, I get to see. Hopefully, I get to have access to Cisco DNA at one point. But yeah, Cisco DNA and wireless control. You got your endpoints, servers, different topology when it comes to networking. So you have your two tier, 3 tier. So any of you who are familiar with Cisco, they have their different layers, which are access, distribution, and core. Spine left, your small office, home office. So very basic when it comes to introduction of network fundamentals. Going forward, it's going to be your network access. So your VLANs, 802.1q, CDP. So this is going to be more into network access protocols. So in an IT environment, you have either one or more than one protocols, to access your devices, right? Not sure if you use servers. You probably are just using Telnet or SSH behind the scenes to log into server, um, or or let's say if you're trying to make changes into networking devices, you're probably using some kind of console or TechX or Radius for AAA, which is your authentication and authorization. So very basic when it comes to network access. Moving forward to connectivity, and this is where you'll see a lot of routing protocols. So when it comes to routing, most companies they have some kind of dynamic routing going on coming from outside, and static. Sometimes you'll see static being used, usually more into a campus or your network. But this is where all your routing is gonna be in. So your OSPF, your default route, network routes, static routes. Keep in mind, I don't see any protocols when it comes to EAGRP and RIP. I know RIP is not being used anymore, but EAGRP is a Cisco's proprietary protocol, and I don't see it on the list. So I think this might be it. Describe, but but yes, I don't see it on the list. So I'm not sure, to be honest. I know OSPF is more open source, um, but yeah, this is something that that I'm hoping that as we go along with the study, uh, from chapter to chapter, hopefully we'll get to see more about it. Going down, it's gonna be your IP services. This is also for a management purpose. So you have your DHCP, DNS, your NAT translations, network address translations that take place. You have your QoS, your voice, depending on your traffic, UDP traffic, and of course your TFTP and FTP. Going to security fundamentals, and this, once again, this is something that I've seen that they have just added. So I've been seeing VPNs, so remote access VPN and site to site VPN, and this is something that I don't think that there are any VPN labs that they will test in CCNA, because they used to test in CCNA security, but since that's gone, I'm not sure what if we are gonna have any VPN lab. I don't think we're gonna have any VPN lab. It's just fundamental, just introduction to VPN. But but yeah, this is something that I've seen that's been added as well into the security list. And going down, this is a completely new topic that they added to this exam, and it's worth 10%, which is automation and programmability. Um, as you all may know, automation plays a key role nowadays, and when you have hybrid infrastructure, such as, let's say if you have your environment, let's say if you have your production environment in cloud, and also at your data center, um, most of your changes now are done through automation, depending on the environment. I know, like big enterprises like United Airlines, and many others, um, they do have automation tools in place where any changes are just done based upon a script, or they use third-party API tools in the middle. Um, Third-party API tools in the middle to push configuration out there. The way I don't come from an automation or any programming or scripting background. I'm more of a networking person. So this is something that they added onto this new exam topic, and it's worth 10%. And also, what I've been seeing is they do have a software-defined architecture. So your Cisco DNA, your SDN will probably, because SDN is more software-defined networking, and they have added this into the topic as well. So this is something that will be really interesting to see, which was never there before into the older CCNA exam. Going further down, you have your REST-based APIs, and you have some platforms. So I'll give an example where I was working on a project for a client, and they use Chef as a configuration management tool. And Chef requires to have agents to be installed into your end devices. So what we would do is we would have agents installed onto, let's say, your PC, and we'll just make, since there's an agent installed onto your PC, it always talks to your backend server, and any changes that we make, it gets updated instantly. So that's what we've been using. That's what I've been using for a specific project, which was to deploy Chef, to integrate Chef into the environment. So it's kind of like a one-stop shop. You don't have multiple tools because these are open source, Chef and Puppet, um, and Ansible. I know Terraform, which is fairly new, which I'm fairly new to. It only works into data center. It does not work on cloud. So these are open source. So you can integrate this configuration management platform, which will work on site and also on cloud. So this is pretty cool. And JSON for your encoded data. So this is a new topic. I'll put a link in the description, hopefully, if you guys want to get the PDF list or PDF file for your reference. Let me just close this out really quick. All right, so yeah, this is the PDF file that I was mentioning earlier. It's basically essentially the same thing, but you can use it as a reference. I have it on my desk, and my goal is to just go to the official study guide and just mark them off as I go through. And yeah, that's about it. Let me pull up the references really quick. And what I will be using to study, and hopefully you guys can use it for your reference as well. I will be using this official study guide book. It's from Cisco, and you can just tell by looking at it. It's 20301. That's the new exam version or the exam name. And in the background, this is a cool picture actually. Those of you who don't know what this is a UCS server in the background. Yes, Cisco do have their own servers in data center, and this is something that I didn't know about. But I got to play around with that in our lab environment. But yes, this is their servers, as you can tell in the picture, and these are blade servers. So each it's like 1, 2, 3, 4, 5. There's like 6 of them, but they're blade servers, so you can actually swap them out. So each one just comes. You can swap them out based on how many servers you need, and you have your controller on the top, where you can control all the servers. So it's pretty cool. You can install a hypervisor and start deploying your resources based on based on based on your needs. But yeah, going back to the exam topic, or going back to the study plan. This is the book. This is the official study guide book, and this is the only book that when it comes to Cisco, that's out there, that you can get one and study for, which is volume 1. So I have volume 1 and volume 2. Volume 1 is mostly based upon it's mostly goes over network fundamentals. So your basic networking 101, your different types of cable, different types of network cables, different types of standards, your basic configurations like how to create VLANs, IP subnetting, IP addressing. So very very basic when it comes to networking world. Let me show you guys the content in the book. Give me just a second. All right, I'll pass it too quick. So, here's the content of the book, and my today's goal is to, is to go over chapter 1 and chapter 2, depending on how long it takes. But I really want to start diving deeper into CCNA, and this is the official book, and you know I'll share it on the stream, so hopefully you guys will be able to take notes, utilize it as we move further when it comes to uh, topics. But my goal is to have a plan, right? Without a plan, we won't be able to achieve a goal. So my goal today is to at least have a chapter 1 and chapter 2, and my plan is to go over some notes that I have for chapter 1 and 2. So we won't be going from pages by pages, and throughout our time, we'll just go like the topics that are important to that specific chapter. So I do have notes for chapter 1 and chapter 2. I'll be going over chapter 3 and 4 later today. I started chapter 3, but I haven't got that far. But yeah, chapter 1 and 2, it's going to be on the list for today. Let's start from chapter 1. And yeah, perfect. Let's start from chapter 1. Introduction to TCP/IP networking. So it's very basic introduction. It's like 101 to networking world, where we'll talk about different type of connections, your single mode, multi mode, like different types of cables, your physical cables, your cabling types, and your interface. So this is a very basic uh, introduction chapter. What I like to do before diving into chapter is to test myself. How much do I know, and how much, uh, how much did I retain after going through every single chapter, and it really helps me for my muscle memory, to be honest, and it really helps me to focus on the areas that I struggle to remember. So this is just like a quiz on how much you know before you start the before you start the chapter, and you can always come back and redo the quiz. But yeah, as you can tell, or as you may tell, for some people, this might be pretty easy. And once again, It depends on your background and depending on your experience when it comes to networking. I'm fairly new to the networking world, so I'm pretty new to this topic. Um, so for me, just some questions that I struggled earlier, some questions I did got it, some questions I guessed, and I got them right. But yes, it's very important to understand these questions. These questions play a key role in the exam because this is your foundation right here, and you don't want to get this wrong because these are the foundations that are being used, and this will be this is being used since past decade, 5 to 10 years. So it's very good to know. These are the questions that you might want to test yourself. Or you can just copy and paste or take notes. I don't care. To be honest, but feel free to uh, take notes. All right. So which of the following protocols are examples of TCP/IP transport layer protocol? So there are different layers when it comes to OSI model, and this one talks about transport layer protocol, which is a layer 4 in OSI model. Let me just share my notes really quick. Give me just a second. We'll come back to my notes really quick. But yes, this is going to be more into layer 4, and those of you are familiar with layer 4, layer 4 has two protocols, which is TCP and UDP. So you have your two protocols, which are TCP. TCP is more connection oriented, and UDP is connectionless. So the way that I remember is one of them does handshake. So what handshake is basically acknowledgments. So every time you receive a packet, it acknowledges that, hey, I got this packet. I received this packet. You can proceed further. And there's always sequence, right? In TCP, so all your packets have a sequence number, so it comes in order. Whereas in UDP, everything is connectionless, so there is no acknowledgement or there is no proper sequence or proper flow, it basically just shoots out all the messages, uh, you know, towards the towards the end device. Whether in TCP there's an agreement, so let's say if I lost a packet, you know, I'll acknowledge that I lost the packet and it will resend me the packet. So it depends. It depends on the use cases. We have seen voice as a UDP, where you know where voice is being used as a UDP. That like streaming is also being used as a UDP, connectionless, depending on the streaming services. But and your TCP, it's such as if I type in Google.com, there's a whole handshake process that goes in the background, and that's a TCP connection that takes place. Your question two is, which of the following protocols are examples of TCP/IP data link protocol? And data link is layer 2, and if anyone who knows about OSI model, your physical layer, it's going to be your layer 1, and your data link layer is the next on the list, which is layer 2. It going on the going from the different options, your Ethernet is going to be your layer 2. Let me mark that off. Your HTTP, that's layer 3. Your IP, that's layer 3. So that's not that these two are in network or internet layer, because it require it's all about IP addresses. Where data link layer, it's more about layer 2. It's about MAC addresses. So think about layer 2 connections. So your Ethernet is gonna be layer 2. Your UDP, this one already got answered before, but your UDP, it's gonna be layer 4, which is transport layer. So that's not gonna be applicable. SMTP, it's layer 3. TCP is layer 4. Your point-to-point, which is a physical connection, that's gonna be layer 2. Going on to the next question, the process of HTTP asking TCP to send some data and making sure that data is received correctly is an example of why. So this is something that I I read into the chapter earlier, which I haven't run into any preparation into CCT or CCENT or networking. Is that they added they go over two. It's very basic. I mean, it's very simple to remember or to understand. But they do go over two different layers. Your same layer interaction and a adjacent layer interaction. And what same layer, you can just tell by the name. It's like same layer just talks between the same layer. So if I have a protocol, let's say a physical layer, let's say I have a fiber cable or a LAN cable, and let's say if there's a protocol that's running on physical layer, it's going to be they're talking to each other on the same layer. So that's same layer and adjacent layer. Those are the two new topics. Same layer is basically any any data that's being sent and received in the same layer interaction, that's going to fall under the same layer category. And adjacent, basically it talks to layer above or below. So usually it's layer above or below, depending on the flow of data. But usually, let's say you start from a physical cable, physical layer, which is going to be your bits, right? Your zeros and ones. Then it goes to layer 2, where your MAC address information is being sent. So that's going to be more into layer 2. And then you're moving on to, then that's where your IP address comes in play, which is layer 3. So when you have let's say your router is talking to your computer, which is going to be a layer 3, but does not know its MAC address. Your MAC address falls into layer 2. So that's where it becomes adjacent layer interaction. Because let's say if router and computer are talking based on the IP addresses, so router knows your IP address, your computer knows the router's IP, which can be a gateway, and they're just talking through IP addresses. That's a layer 3 connection, which is a network or internet layer connection interaction that's happening. So that will fall under same layer interaction. But let's say in this case, in this question, the process of HTTP asking TCP to send some data and making sure that it's received correctly. So HTTP falls into application layer, so all the way on the top. But it uses, but it uses TCP for TCP transport layer protocol for acknowledgement. So this in this case, since it's using different layer for interaction, this is going to be a adjacent layer interaction. Let me mark that off. If it allows me how to do it. I don't know why I couldn't get it in once. But that's going to be an adjacent layer interaction. Moving on to the fourth question. The process of TCP on one computer making a TCP segment as a segment 1. Alright. And the receiving computer then acknowledging the receipt of TCP segment 1 is an example of why. So as I was talking about earlier, there's always an acknowledgement that takes place in transport or TCP, which is a protocol that's in transport layer. Is that it is a connection oriented. So every time a sender receives a data from receiver, every time a sender sends a packet or a data to a receiver, the receiver has to acknowledge it by saying, "Hey, I got this," or "Hey, I missed this. Can you please resend it?" So there's always acknowledgement that takes place in TCP or a networking world. We call it as a handshake. And this is going to be an example of the same layer interaction, where you can see that one computer is sending a packet or a segment or like a data to a different computer, and that computer agrees that, hey, I got this packet. But they're talking the same layer. They're not using any different layers to make that process to happen. So it's going to be a same layer interaction. The process of a web server adding a TCP header to the contents of a web page, followed by adding an IP header, and then adding a data link header and a trail is an example of what. So this is going to be an example of data encapsulation. Let me go to my notes really quick. We'll come back to it in just a second, but I really want to go over data encapsulation. This might be a new topic for some people, but basically, what your encapsulation flow will look like. In typical, this all can be seen or captured through Wireshark. Through Wireshark. You can run like a virtual machine, and you can just ping google.com, or ping internally, or just have a loopback address and just ping it to yourself or ping it to your router, and you can capture packets behind the scenes in Wireshark. And hopefully, I get to play around with my Linux machine after this, so I can present it to you guys for tomorrow. But yeah, it's just when it comes to encapsulation process, is that you start from this one. This one goes some other way around, but these are the 5 steps that take place. And as I was talking about different layers, physical layer, your data link layer, network, transport, and application. So let's say I have some data. Let's say I'm a computer and I have some data that I need to send it to someone else, to a different server, or to a host. And a host is basically anything with an IP address. I have a data that I need to send it to a host. I have a data, and what happens when it moves from application layer? It will go down to transport layer, and that's where you have. That's where I'm not sure if you guys can recall from the previous question. there were two protocols that run on transport layer, your TCP and UDP. So in this case, let's say it's a HTTP data, and HTTP uses TCP. This will have a TCP header that will get put in the front of the data. Moving down from TCP, it will go down to the network. So let's say this one is your destination address, which is gonna be your you know your receiver's IP address, um, or the IP address that you try to send this information to. And once they receive, once it's being sent out and once it's acknowledged, then it goes to data link layer, which is this is going to be a layer two. If you look at, if you start from bottom to top, or in this case we're just going top to bottom, but it's going to be a layer two. It's going to be a data link layer, and which fifth layer it's going to be your physical connection, which is all your your wiring, zeros and ones, right? That's gonna be into your physical. That's gonna be in your physical link, which is gonna be physical data link network transport application. This is gonna be your five steps of encapsulation. But going back to the question really quick, the process of a web server adding a TCP header to the contents of the web page, following by an IP address, and then adding a data link header and trailer is an example of what. So that's going to be an example of data encapsulation, which you can see right here. This is what it takes place behind the scenes every time every time you request something, depending on the data, depending on the protocol, and depending on what layer that protocol resides within. All right, let's move on to question 6. Which of the following terms is used specifically to identify the entity created when encapsulating data inside data link header and trailers? Wow. This one is about PDUs. So if you guys don't know what PDU is, PDU stands for Protocol Data Unit. And basically what it is, it's basically headers and trailers. So every time a packet that's being sent out, or that's being passed on from different layers, it adds a header. So let's say if I'm a layer 2, which is data link layer, and if I'm sending a packet out to layer 3, which is a network layer, what's going to happen is that I will be adding a packet. So in this case, let's say I'm layer 2, I'm a switch, which switch acts as a layer. Some switches act as a layer 2, and some acts as a layer 3 with routing on it. But let's say I'm just a simple switch, which is layer 2. So I will have the header and a trailer. And the reason why layer 2 is the only one that has a header and trailer is because of FCS, which is frame check sequence. We'll get back to it later as we move on from chapter to chapter. But this is the only. I mean, I wouldn't say this is the only layer, but it's done. I believe it's done for it's. I forgot. I think it's done for error check. So just to make sure that your bits add up, kind of like an MD5 check that you can do, where every time you download a file, you can compare the MD5 for integrity of that file, so you can tell if you got the wrong file, or if that file was changed throughout the download process. So that's where it's more of an integrity check that takes place. I'm sorry, it's called frame check sequence. That's what's it called. And once again, we'll dive deeper into each layer in each packets, each layer and different bits and different packets and what they do. But just for understanding the question as of right now, is PDUs are added at each layer. So, and that's how that's how they talk. That's how they talk at each layer. So if I'm layer three, if I'm layer three, what I look at is I don't look at the data. I don't care about the data. I care about the header and the trailer. In this case, if I'm layer three, I'll look at, okay, this packet has a IP address of this host or this router. So what I'm gonna do is I'm just gonna push it towards that IP address. So that's what it is basically. It's headers and trailers for that layer as well as the encapsulated data. So in this case, going back to the question, is which of the following term is used to specify, to specifically identify the PDUs or inside data link header? In this case, let me go back to my notes. Each layer has its name. So in chapter 1, it's introduction to basic networking, and when you get into networking world, there's a model or there's a communication standard that's already in place. So in this case, if I'm a vendor and if I'm coming out with a product, uh, this OSI kind of sets like a ground rules of like on like how they need to communicate. And basically OSI model is just used for as a reference, right? um, your older CCNA, or your previous CCNA or any Cisco exams, there were 7 layers. So starting from physical layer, data link layer, network, transport, session, presentation, application, there were 7 layers that were added. Uh, you know, that were, but the newer exam focuses more on focuses on 5 layers, which is your physical layer, data link layer, network, transport, and application. So you only have 5 layers going into the exam. Keep in mind that session and presentation, are that's gonna be now your application layer, which is gonna be layer 7. So it's essentially the same, or it's essentially the same model, but now it only has 5 layer. They go to 5 layers instead of instead of having session and presentation on the list. So that's gonna be your new TCP IP model. This was your OSI model. This one's more TCP IP model, and this is the model that they have in the study guide, or for the new exam. So just keep in mind that it's good to know your older model, because once again, your architecture, it's gonna go through the same data flow process, but in the exam they're gonna test you in 5 layers, which are physical layer, data link layer, network, transport, and application layer. So in this case, different layers. Let me just go back to my notes. Probably forgot to add that on the list. Oh, there it is. So, when it comes to different perspective of encapsulation and data, every layer has its own term. So you probably heard it from someone in your team or from a professor. It's like, hey, this packet does, for some reason this packet is not going through firewall or going through this network. When they really mean packet, is they're talking about a layer 3. They're talking about layer 3. So in this case, like, hey, I'm looking at I'm running some background network sniffer, and I got this frame, and the it has the right IP address, but the MAC address is not the one that we have on the file. So I'm talking about layer two. So they have their own terms when it comes to they have their own terminology when it comes to encapsulation process. And in this case, frame, it's gonna be your layer two. Packet is gonna be your layer three, and your segment, it's gonna be your layer four. So please keep that in mind. So in this question, it's asking about which of the following terms is used specifically to identify the entity uh, created when encapsulating data inside data link header and trailers. So it's gonna be a frame. All right, which OSI encapsulation term can be used instead of term frame? So this is gonna be your PDU. So it's gonna be your layer 2 PDU. And going back to how I got this, is I'm using this as a reference where your frame, it's gonna be your layer 2, which is your data link, and your packet, it's gonna be your layer 3, and your segment is gonna be your layer 4, which is TCP or transport. So in this case, it's asking for the question is uh, which OSI encapsulation term can be used instead of term frame. So I can call as a layer 2 PDU. And once again, PDU, and what PDU is, give me, oh, there it is. PDU is just header and trailer for that layer. So now we know that data link layer, it's layer 2. I can call as a layer 2 PDU, or I can call it as a frame. It just depends on your preference. So in this case, by just looking at this figure of encapsulation and PDUs, I can just say that, hey, it's a layer 2 PDU, it's a layer 3, 4, and going forward. But keep in mind that layer 2 is also known as a frame, so it's also going to be your it's going to be your data link layer. All right, so those are the answers. I already have the answer key with me, so they are pretty much all right. Let me go back to my notes, and I'm gonna go. I have chapter 1 and chapter 2 for our reference, but I'll be starting from chapter 1, and we'll just work our way down. Chapter 1, and these are the terms that I have, and some status codes, that you probably or we probably just run into once in a while. For terms, these are just the basic terms. Your first is URL, your universal resource locator. Your HTTP, hypertext transfer protocol, your HTTPS, which is secure, IEEE, RFC, your DDN, OSI, which is Open Systems. It's not system, I forgot, but Open Systems Interconnect. So these are just the terms that I that I run into or that I ran into while I was going through chapter 1. And once again, this is something that just keeps me understand what they are. Especially in networking world, IEEE and RFC are going to be two big main ones, because IEEE is the one who will come up with all the Ethernet standards. So those are the guys, or those are the engineers that will come up with standards of like, hey, if you're using a fiber cable, or if you are using any Cat 5, Cat 6 cable, this is the standard that everyone needs to follow. So if you're using like a copper cable, well, we are limited to 100 meters. So you can't. The standard is you can't go more than 100 meters. You have your different different categories. Your Cat 5, Cat 5e, Cat 6. So IEEE is the one who will come up with the standards. And what RFC, and you gotta look for RFC. RFC stands for Request for Comments, and that's where your protocols are defined. So your just going a little bit down right now. It's your IP, ARP, and ICMP, and any protocols, any secure protocols, they are defined by a RFC standard. So your wireless protocols, um, your layer 2, layer 3, any protocols when it comes from layer within OSI model, they will get defined by RFC. So that's how I remember. It helps me remember, and it's like, hey, IEEE are those electric and electronics engineers who come up with Ethernet standards, and RFC it's gonna be the one that go over RFC is the one that go over protocol standards. So that's what I have. When it comes, that's those are some key differences that will help you in the exam. So going down on the list, once again, you're older, OSI model from previous exams, or if you're studying for any Cisco certification before, there were 7 layers, but going forward with the new exam, keep in mind that there will be 5 layers that that you'll be tested on, which layers 5. Let me change this really quick. So your 5 session and presentation are basically aggregated into layer 7, and keep in mind that they still exist. It's just that when it comes to looking at the model, it's only going to be 5 layers. All right, let's look at TCP/IP. So your TCP/IP, once again, these are the protocols, are the documents, which are RFC. So you can actually go to the RFC website. Let me see if I can pull it up really quick. RFC, request for comments. All right. Your RFC index. There it is. So this is gonna be your one-stop place. So as you can tell, there are thousands and thousands of protocols that are being published, right, and that are being out there. And the way that you can search for it is by typing in the RFC number. There's a search index on the top, but I forgot past it. But this is where you would come and yeah, this is where you would look at the documentation. And trust me, guys, hackers would actually come here and go through, like, there is Telnet. Um, they would go through this documentation and they will find flaws, and that's what they will use. You know, you know, that's what they will use to get into the network. So and these will get updated from time to time. As we discover any flaws or any more any tweaks, from time to time. So that's why you have SSL with different versions. But yes, this is gonna be your one-stop place for RFC, and I'll add this link onto the notes onto the stream as well later on, so you can use it as a reference. But going back to my notes, this is gonna be your TCP/IP, which uses your RFC, request for comments, for protocol. Your Ethernet are those IEEE guys, right? Those engineers, electric and electronics engineers, who will come up with different standards. And going to this same layer and adjacent layer, and we talked about this because there was a question that was asked earlier. The way that I remember same layer is that they communicate within the same layer on a computer. or on a device or on a network, right? So anything that communicates, if you have a computer with IP address talking each other through IP address, that's a layer 3 communication. So that's going to be the same layer. Adjacent is going to be which requires upper and lower layers to finish the tasks. So this is where let's say I plug in a physical connection to my laptop. I connected my modem or router to my laptop through a wire, and now my router detects its MAC address, and now it has an IP address. Now they're talking. Talking to each other based on layer 1 and layer 2 and layer 3. That's what's gonna be that's what's gonna be a good example for adjacent layer. Also an example for HTTP. Similar example. Um, similar example that we've seen earlier from the practice exam, which is let's say HTTP wants a recovery, it will go to the lower layer, transport, you know, go to layer, to get whatever needs to be done to complete the task. Let me update that to complete the task. All right. All right. So what I have here, it is a just a quick table that I created through Excel as different layers that we've been talking about. So OSI model and your older and your new OSI model. And what are some protocols? So these are the protocols that you will see in RFC or you'll see in the quest for comments. So these are some protocols that that you'll see or that are defined into the standards. Let me see if it's too small. I can make it bigger, but but on physical layer you have your 802.11. On layer 2, which is your data link layer, this is where you have your MAC addresses. Your network layer has IP, ARP, ICMP. So every time you ping a computer, it uses an ICMP protocol. For your transfer, you have your TCP and UDP. And your application, HTTP, POP3, SMTP, which is your all your mail exchange and all the HTTP, HTTPS. It's gonna be in this application. There's much more to it, but just for our basic understanding, this is just a few. We'll keep adding more, and I'll make sure to add this on every chapter. Mostly every chapter that we run into. If we run into any protocols that belong to this layer, so we're probably gonna have Telnet, SSH, SMP going forward. But this is just some. There's many out there, but this is just a few on the list, just to understand how the architecture and what protocols they rely on to. Moving on to PDUs, every packet has a PDU, and this is going back to the picture that I have in the bottom, which is going to be this one right here. Let me take this aside. We're going to need this for right now. There you go. Perfect. So you have your data link layer. You have your you have different layers, right? You have your you have your file layers, and each layer has their own PDUs. So in this case, your layer 2 will have their layer 2 PDU where it has header. There's a reason why layer 2 has trailer. And once again, we will dive deeper into it as we make progress along with from chapters to chapters, and as we cover more topics. But just for right now, for your notes, I would just stick with layer 2 header and layer 2 trailer. But just to understand the topic, it's like, let's say on Cisco, on the new Cisco exam, if they ask you about hey, this is a layer 3 PDU. Um, and, what are some things that are in layer 3 PDU? So, for your understanding, you know, and you can use OSI model here. Let me Let me see if I can. Yeah, I can put this. So if I have OSI model, so if I have OSI model right here, um, it's gonna look a little weird, but I'm just putting this as for our perspective. Um, is that if someone asks you, it's like, oh, layer 2 PDU, you would know what you would come, if you have the TCP IP model, remember, you can just come here and use as a reference. We're like, oh, the question's asking me for data link layer, so that's gonna be when they ask for layer 2 link, they probably, what are some protocols, what are some things that I'll be looking for in layer 2 or layer 3. So let's say if they ask for layer 3, and one of the options is IP address, or ARP or ICMP. I know that that's gonna be in layer 3 PDU. Let's say if they ask me about TCP or UDP, and they ask me, hey, what PDU does this belong? That's gonna be in transfer, which is gonna be layer 4. So it's going to be a very helpful OSI, OSI model and TCP/IP model is going to be your key when it comes to answering these questions. Let me see if I can move back. There it is. Perfect. Once again, let me know if this is smaller. I can make it bigger if you like. All right. So let's see where your PDU is. Your encapsulation, which is gonna be process of putting headers and trailers. Give me just a second. Let me just move this around. Just copy and paste. See if I can. Oh, I can. Perfect. Okay. All right. So your encapsulation process, right? This is gonna be where you're gonna have headers and some trailers at each layer. So when it comes to encapsulation process, going back to this chart one more time, is that um, you're gonna have your TCP header, you're gonna have your IP header, you're gonna have um, your data link header and trailer. So that's how they talk to each other. Is through it's through adding headers and trailers as they move along between different layers. That's how they know which layer they belong to. So, let's say if I receive a packet at layer 2, uh, let me just go back to your OSI model really quick. Probably moved it in the bottom. Let's say if I receive a packet at layer 2, I can, uh, what's going to happen is that let's say if I receive someone a packet from layer 2, okay, let me put it this way. Let's say if the router gets a packet for layer 2, so what's going to happen in that case is that, since it does not belong to, since it does not have any IP header or IP or any IP information in the packet, it will just transition to layer 2, because it has all the information that it needs to push it onto the switch. So if it has a destination a MAC address, or let's say the router has a ARP table where it's like, oh, I know that this device is connected. This MAC address is connected to this port. For example, switch. I know that this MAC address is connected to this port on the switch. What it will do is it will match the MAC address and it will send the packet to that host or PC. All right, so this is just for a small reference. Your small office and small. I know that the CCNA goes over this topic. So going back to the CCNA guide, give me just a second. Let's see. Oh, there it is. Your small home office, and it goes under 1.2, which is describe characteristics or network topology. And what I have for network topology, when it comes to small office or home office, is your typical office. Let's say you have a typical small office. What it will look like, what it will usually look like back in days is you have your printer, you have your department. Let's say this is an HR, this is your accounting, and this is your finance. Everything will go connected to a switch or a hub, and then it will go, it will connect to your router to go outside the network. That's what your typical small network will look like. But and but like into this small offices, it's just more to it, right? You have an access point, where that's where you have everything connected to you. Your end users are connected through Wi-Fi. End user devices, tablets, phones. You have your guest network and all that stuff connected through Wi-Fi, and then you have your office stuff connected through switch to your router. Um, to go out to the internet. That's where your typical small office, home office will look like. And when it comes to enterprise, uh, y- your enterprise is a little different because think about an enterprise as a building or like like, like a college campus or a school. You have your floor, you have your first floor, you have your second floor, you have third floor, and within each floor you probably have like thousands and thousands. Well, not thousands, but like you have about like about let's like 20, 30 offices. This will look a little different, but it's just keeping in mind to understand like how far we are coming to networking world. And the bigger the bigger your infrastructure will get, the complex your network is going to be. So this, just use it as a reference. I'm you know pretty sure no one's using this right now, but you might run into a company down the road, or you might end up working for a client that has a similar network architecture, right? But this is what it will look like. So each floor will have a switch, probably more than one switch. For backup, for redundancy in the environment, just in case if one fails, the other will come back up for failover reasons. But in this case, there's only just understanding where we come in networking world is that we have your end user devices, you have your access point, then you have a switch. Each floor has each switch. That's where all your devices will get plugged into. Your access points and your end user devices, and then it will go back to the main switch, which can be in the basement, which can be in your data center, and that switch is connected to the router, and that router will give you access to the internet. It's not that complicated, but yeah. And that's in chapter 2, but just really wanted to quickly go over it. Just go over that really quick. When it comes to small office, home office, and based on what I understand from my previous CCNA practice exams, is they usually have pictures, and they will have you identify devices. So they will have this like, hey, what device is this? Oh, this is an access point. Okay, can you just drag and drop it to that device? So they usually have like a drag and drop question where they will have a list of things. You just drag it to where it belongs. So it's pretty straightforward. They're not gonna ask you any crazy questions about like, hey, how long is this cable? You know, what cable you should use. Nothing too technical. Just understand the concept. When it comes to when it comes to architecture or topology when it comes to small office and home office, and also kind of understand the big picture on like how it's being implemented on a enterprise level. All right, so going down further is the standards. So if you remember from our previous notes, is that IEEE, which are those electric and electronics engineers, those are the ones who come up with different standards. Um, and and you probably seen this. Uh, you probably may have read about this if you're preparing for any Cisco certification. If you already have any Cisco certification, or just doing any IT infrastructure work, is that there are some limitations and there are some different standards that you can implement when when you're wiring your offices and your campuses and your enterprise network. It all it all starts with speed, right? 10 megabytes. Nobody uses 10 megabytes anymore, but your 10 megabytes, it has a name. Common name is Ethernet, which is 10 bit C 802.3. Um, your cable type is going to be your maximum length, which is your 100 meters. Um, your fast Ethernet, which is 100 meg, it's known as 802.3U. So like the reason why you need to know these names is because they might ask you and they might ask you an exam question, right? It's like, hey, what speed is 802.3U? And you have a bunch of options in the list, like, oh, is it 10, is it 100, is it 1,000? So this is very important. This is very, very important to exam topic to remember. And once again, you can take a screenshot or you can take notes while you go. But please do remember that this will be asked on the exam. Not everything in it. They might ask you one or two questions, but you will have to prepare this table for the exam. So you have 1,000 megs, which is 1,000 megs LX. The way that I remember is anything with X at the end, it's fiber, and anything with the T is copper. I have it on my notes, not on this one, but I probably have it in my notes in right here. Give me just a second, there it is. Let me put that here so you guys can use it as a reference. And let me move this down. Oh, did I get the wrong one? Give me just a second, there it is. Give me just a second, guys. Let me see if I can edit it. If it lets me edit it. Let me see if we can put it here. There you go. Perfect. Or I can put it in the side. I think this would be better. So it's good to know that T stands for copper, and anything with the T is gonna be copper, and X is gonna be fiber. It's just a trick that I remember going to the exam, because once again, you only have 2 hours, and there's just more into it. So you don't want to be stuck. These are like easy points, gainers for the exam. It could be a quick 1 point or 2 point, depending on the scale of this question in the exam. But anything with the X at the end is going to be a fiber. Anything with the T is going to be a copper. So in this case, there's a standard 1,000 base LX. The name is it's 802.3Z, and it's fiber. And fiber, everyone knows that fiber can be used for long distances. So this one has 5,000 meters. Going to next one, which is 1000 base T, 803.AB. This one's 100 meters. Next one is 10 gigs, which is 803.AN. This one's copper. So make sure you guys do remember the different names that goes with different speeds and the limitations when it comes to cable type. So I can implement copper if I'm going 5,000 meters. I need to go with a different option, which is going to be my fiber. So what is fiber optics? Fiber optic is a long, thin strands of fiberglass. And let me see if I can pull up an image of what fiber cable looks like from inside. They are very expensive, but they are used for long distances, and you will see them in the environment. Let me see if I can find a. I'm not sure if anyone has used fiber cable, but usually there's a light. Um, this one looks way too flashy, but usually if you look inside, uh, this is what this this is an LFC connector, but uh, but usually if you look inside this cable, you will see a red light coming through. If you don't see any red light coming through, which means either the port is down or either your configurations are messed up, or you have a bad fiber cable. But yes, that's that's what fiber cable is basically. And usually it's very fragile, and you usually have those, and it's not twisted. Keep that in mind because usually your coppers are they usually twisted in pairs. But fiber cables, you cannot twist fiber cables because of glass and the material, because you don't want to damage anything that's inside. That you don't want to damage the glass inside it. All right, going back to the notes. Is it contains long thin strands of fiberglass. Yep, so you don't want to destroy your fiberglass that's inside the cable. The attached Ethernet nodes, Ethernet node sends light over the glass fiber in the cable, encoding the bits as changes in the light. Perfect. So once again, if you plug in the fiber cable, and if you don't if you don't have access, if you don't have if you don't have a device that uses a fiber cable, you can just watch a YouTube video, or just get a Cisco switch, get one of the connectors that I'm going into. That's going to be next on the list. Uh, uh, just get one of the connectors and just plug in the fiber cable and play around with that. That's the best way to learn. Just you know, some hands-on experience when it comes to networking world. But keep in mind that 10 base and 100 base T uses 2 pairs of wires instead of 4. Those are the only two. Rest of them uses 4 pairs of wires. 4 pairs. It only applies to copper, not fiber. But your 10 and 100 meg uses 2 pairs, and that's the question that they asked me on CCT. So I won't be surprised if they ask me on CCNA. What's Ethernet link? Your link is basically anything that's connected. Refers to any physical cable connected between nodes. So that's going to be a link. What are some connectors? So if you have a Cisco switch, or in your environment, if you have Cisco switch with, let me see if I can get it. This is what I have. But let me get a. Just trying to find a good example for reference. Let me see if it allows me to. I'll make it a little bigger so you guys can see it. And I'm gonna upload this on YouTube later on. But as you can see, this is what your typical switch will look like. I don't know why I zoomed in too much, but I could have just opened this picture in the tab. But anyways, let me see if I can make it better for you guys. See it better from my end, but I wasn't sure if you guys can see it. But usually, on your Cisco switch on the right side, this are your ports, right? So depending on the switch, some switch will have this one has 24 ports. This one, some do have 48. But on the right side, you will see this. You'll see the slots, and this slots would this is where you would go and put in your fiber modules, and there are different types of modules that you can put depending on the switch. If you have an older switch, it will use different. It will use different. It will use different modules. So it says however for Zoom, but it doesn't let me. Yeah, it doesn't let me. But yeah, when it comes to the modules, is let me go back to my notes. There are different modules that you can use depending on depending on your speed and depending on what form factors it uses. So on the right side, let me make this bigger so you guys can see it. There are different types of modules. There is a gigabit Ethernet interface connector. It's called GBIC. This is the original form factor. It was very bulky to use, and as you can tell just by looking at the picture, right? These are your SFP modules. This is like an old school. Well, not I wouldn't say old school. They're still being used, but these are the first ones. That they came out. Uh, um, for gigabit interfaces. They are larger than SFPs, and this is a small form pluggable. As you can tell, they're like a they're kind of like a flash drive where you can just plug in your fiber links um, uh, into it. So these are replacement of JPEG. Um, much more wise, they take less space. So now you can have more ports, or you can have more modules on your switch, rather than having a big, a big slot for just for JPEG. And SFP Plus, SFP Plus is used for 10 gigs. So SFP anything, it will take anything except 10 gigs. SFP Plus is just similar module, but only used for 10 gigabit interfaces. All right, we're almost done for the day, but really quick. Um, this is something that everyone knows, or it's very it's very basic foundation when it comes to network flow between two devices, right? Here in this case, we have a PC. We have a PC on the left, and we have a switch on the right. So the way it works is, first there is a circuit that needs to be created. So think of this like a loop. That's a circuit, because you need a circuit for two things: one, to transmit, and two, to receive. So in this case, this device will transmit to the receiver, and the receiver will use this end of the circuit to transmit, to send anything that it needs to send it to the transmitter. So in this case, the way that I remember is uh, you have a receiver and you have a sender. So think of transmitter as a sender. So this one uses this lane of this circuit to send it to the receiver, and receiver will use this lane to send it to send anything that he wants to the sender. So the way it works is there has to be a circuit. It's very simple understanding that there has to be circuit, right? In order for it to simultaneously send data back and forth. If there's only one circuit and if they're trying to talk back and forth, guess what? It's not gonna work. So that's why it has a circuit, so it can send and receive at the same time rather than just waiting to do one thing at a time. So using this situation is that typically when you plug in your PC and when you plug in your switch, uh, in networking world, 1 and 2 will transmit. So 1 and 2. So if I'm a PC, what I'll do is if you look at the fiber cable, give me just or I'm sorry, if you look at the copper cable. All right, so let me get this picture really quick. All right, so your typical cable, your typical network cable. So I'm not sure if you have any cable laying around, but when you look at your typical network cable, or your Ethernet cable RJ45, let me close this really quick. We don't need this anymore. As typically you have, if you look carefully, you have total 8 pins. And what happens is that when you have when I plug in my computer, my PC to the switch, so just use this as a reference once again. Give me just a second. You'll have. Let's try to show you what it will look like. Just a snippet. All right. So what will happen in this case or in this scenario? What will happen in this case is your 1 and 2, which is going to be a 1 and 2 pin. This will have a circuit, and this circuit, and this will create. This is where they will transmit. So my computer will transmit it from 1 and 2, and the switch will receive at 1 and 2. I'm sorry. Yes, the switch will receive at 1 and 2, and also in this case, um, this is and switch will use 3 and 6 to send data to me, and this is where I will receive. So the way that I remember is that PC uses 1 and 2 to send and receive packets from switch. So having it visually, it really helps you understand how it works. So remember, let's say if you have a 10 base and let's say you have a 10 or 100 base network. So going back to the network table, you have a 10 base network and 100 base network. Um, what you'll use it as a reference where okay, you have 2 pairs. Remember, 10 10 base and 100 base have 2 pairs of cable. So this is the one pair and this is the other one. So in this case, your 1 and 2 on PC will transmit. Let's see if I can draw really quick. I don't want to put any links. Let me see if I can just draw. Oh, this is gonna be a full attempt into drawing world. I'm not a really. Uh, uh, maybe not. Only if I can move this arrow, I can figure the rest things out. But it wouldn't let me. It wouldn't let me. Yeah. Or maybe it will. Well, I'll figure it out later. And I'll make this usual much better. I can draw. I'm really not good at drawing. I can get a shot. All right. So you want. Yeah. Please do not judge my drawing. And you want. Wow. Oh, what did I do? So this is your one. I'm gonna take it out. And this is your two. So you have your one and two where your PC will send it, and that's where your switch will receive it. And then you have your 3 and 6. Let me see if I can make it a different color. Guys, once again, I'm not really a great artistic person. But this is where you have your 1 and 2 and 3 and 6. Wow, that's the worst drawing in my life. But this is where you have your 1 and 2 and 3 and 6 talk to each other. Where the way that I remember is that one's gonna be your receiver and the one's gonna be your transmit. So if you know 1 and 2 is gonna send out stuff to switch, you know that's where 1 and 2 will receive. And if you know that 3 and 6 that's where your computer will receive all the information from a switch, this 3 and 6 that's the one that those are the two pins that are being used by switch to transmit. The way I remember is that they are flipped, and this is just a this is another example on how they talk. So Larry, let's say we have Larry and Bob are usually used in most of the examples when it comes to IT world. But let's say on the left, I have my computer that's plugged into the switch, and my computer has a NIC, which is network interface card. Um, and I plug in to my port, network port or Ethernet port using RJ45 cable, and I'm plugged into the switch. So my computer will send information, so send all the data at 1 and 2. That's where switch will receive at 1 and 2, and once it has encoded anything that it needs to do, it will send me back through 3 and 6, and that's where I receive at 3 and 6. And this applies on straight through, which is there are two types of cable that can be used. There is a there's a straight through cable, and there's a crossover cable. Straight through cable are used to connect your unlike devices. So your switch to a router, your PC to a switch. Crossover cables are usually used to connect same devices. So let's say if I'm connecting one switch to another switch, I won't be using straight through cable. I'll be using crossover cable. So the way that I remember is straight through cable. That's where your unlike devices, which are your devices that are different from on both ends, will be used to connect with each other. And crossover are the ones that I will, that we will use to connect between two same devices. Um, so please do keep in mind, and feel free to take any screen captures from my notes. Um, Unfortunately, I have to end this. It's 1 hour and 30 minutes. I will be uploading this later on, and I will be also putting it on YouTube. So I'm still working on my YouTube channel, and once I have that updated, it's gonna I won't be able to update it until tomorrow, but yes, all this will be on the channel pretty shortly. So feel free to you know leave any feedback, any suggestions on how to make it more efficient, because as always, but there's always room to grow and be more efficient. So feel free to leave your feedback. And yeah, that's about it. And thank you for joining. Hope you have a good night and a good weekend. Take care.